Greetings. This is chapter 14, part 1. This is the first lecture still, but video 2. Now, we've been talking about weak acids and weak bases, and I want to remind you how weak bases are actually a weak base. These hydrolyze, which means they react with water to produce hydroxide and the conjugate acid. So the generalized formula looks like this. You have some weak base in solution. It reacts with water in liquid form here, and this is in equilibrium with the conjugate. I'm going to change this to A minus just to be consistent with things. So this will go to the conjugate acid, and it will produce a little bit of hydroxide ion. Okay, so this is the conjugate acid. So you can see in this pattern, the base gets transformed into the conjugate acid, and there's small amounts of hydroxide ion present. Okay, and so we know that this is in equilibrium. This is the major dominant side of the chemical reaction. These equilibrium constants are very small. Okay, so the Kb value is small. So this means the left side is favored. Okay, and the right side, or the products, are not favored. They're disfavored. So in solution, for example, we might have 98% of A minus, and we might have only about 2% of the conjugate acid and the hydroxide. Okay. Now the Kb for this chemical reaction, B, remember, is for base, is going to be equal to the products over reactants. We've got HA, hydroxide ion, over A minus. Okay, and there's no water. Water is a liquid, right, and does not enter into the equilibrium expression. So we have the two products here, which are both aqueous, and one of the reactants, which are aqueous, and it's products over reactants. The balanced chemical reaction, there's a coefficient of 1 everywhere, so we don't need to show the first powers on all of these concentrations. Okay. Now, let's write this equilibrium out for an exact example. Let's show the base hydrolysis reaction. For hypochlorite. This is bleach. I suspect a lot of people are in need of this recently. So hypochlorite is a weak oxidizer, destroys bacteria and things like that. So now, what we do is we write down this guy here, and you'll see this in Appendix 3. So if we take a look at Appendix 3, you can see ClO minus right here. Okay. And it has a Kb value there that we'll use in a second. And here's the conjugate acid, okay? This is hypochlorous acid. There's a mistake kind of here. This is hypochlorous acid, okay? And this is hypochlorite. All right. If your acid ends in ic, the ion is going to be 8. If your acid ends in ous, the ion is going to end in ite. Okay? let's look at that. So benzoic acid up here, this would be called benzoate. Okay. Acetic acid is right here. This would be acetate. And let's look at some us acids. We have sulfurous acid. Okay. So this would be hydrogen sulfite. This is hypochlorous acid. This would be hypochlorite. Okay. So now you kind of know the naming conventions of these oxyacids and so on. Now, in the chemical reaction, we want to draw the reaction between hypochlorite. This is your base and water. And that's going to be in equilibrium with HClO. This is going to be the conjugate acid. Okay. And that's, of course, water. I mean, that's aqueous. And then we have a hydroxide ion present. Okay. And that's just called hydroxide there, okay? So your base gets transformed to your conjugate acid. That's the overall trend. Now the Kb for this is going to be equal to products over reactants. So we have HClO, which is neutral. We have OH, which is a -1 ion. And that's going to be all divided by the reactant. Now this is water, so it doesn't enter into the equilibrium expression. So we write hypochlorite ion like that, ClO negative. And this value here has a, let me show you in the appendix here. You want to look at the Kb column up here, okay? And it has a value of 3.6 times 10 to the -7. So that's equal to 3.6 times 10 to the -7, okay? Now what I want to review to you is calculate the percent ionization of hypochlorite. And we'll use 0.1 molar sodium hypochlorite, okay? And that's technically bleach, the sodium salt of that, okay? All right, so what we do is we throw away the sodium, okay? The sodium ion is just a spectator ion, and ClO minus, that's of course the, the weak acid, okay? So we're going to use that. So first write out your equilibrium. Forgot the water here. Okay, write out your conjugate acid, your hydroxide, okay, and we want to use our concentration here as the initial value. It doesn't matter what water is because that's a liquid. It does not enter into the equilibrium expression. None of these others, okay? We ionize slightly to produce some of these ions over here on the right side of the chemical equation. So we have 0.1 minus x, x, and x. And what we want to do is plug this into the equilibrium expression, right? Products over reactants. But we know what the value is. It's 3.6 times 10 to the -7. And that's products over reactants. Okay? And remember the assumption that we make here. We assume that x is small because we're dealing with weak bases with very small equilibrium constants. So we assume that 0.1 minus x is about equal to 0.1. And that simplifies the math a little bit so that we don't have to use the quadratic equation. And we get that. And then using your calculator, you can do that, and then the square root, x is going to be equal to 1.90 times 10 to the minus 4. So you can definitely see that x is pretty small here. Now, percent ionization, recall, would be the amount of the the acid or the ion that's produced per this. So it would be you're not realizing this is usually only done for acids, but we'll fake it for the base here. So we'll calculate the ratio of the HClO over the ClO minus, and what we'll get here is 1.90 10 to the minus 4 over 0.1, and I want to multiply by 100 just to move the decimal place over in my calculator. And what do I get? I get 0.19. Okay. So why am I doing this? I'm just impressing you that this chemical reaction is, let's do 100 minus 0.19 just to take a look at that. In solution, a solution of bleach, you have 99.8% of this stuff, okay? And you have very few molecules of hypochlorous acid floating around, which would be like 0.2%, okay? All right. So now that you know how to do this, try to write out the equilibrium for the hydrolysis of carbonate is CO3 2 minus, okay? So I'll help you set that up, okay? Complete that, okay? The next thing is to write the equilibrium expression. So this is a reaction, okay, a chemical reaction with the equilibrium arrow. This is an equation with the mathematical equal sign, okay? So write out what the Kb is, and that's going to be equal to, your usual things. So fill those blanks in. And the third thing is to calculate percent ionization. You gotta put that in quotes, just like how I just demonstrated it for your base, okay? And the final thing is to compare these two bases. Is carbonate more basic or less basic than hypochlorite, okay? And you'll enter these answers into your worksheet.